also a speaker, so I will present myself. I'm Yahya Tayalati from University Mohammed V in Rabat, but I'm also affiliated to University Mohammed VI Polytechnic in Beirut. I would like first to thank the organizer for giving me this, for their kind invitation and giving me this opportunity to present some of our activities, and especially Asren and my colleague Dr. MARWAN. So thanks a lot. My presentation is entitled Clouds for High Energy Physics. I will more focus on what we do with the cloud in high energy physics. And it's impossible to present all Moroccan activity in this field, so I will also focus on what's going in Rabat. So this is the outline of my presentation. Please forgive me, I will bother you a bit with some physics in order to see what's going on. I mean, Morocco is very visible in international collaborations. So I will present some results in Atlas. It's high energy physics with the Large Hadron Collider in Geneva, and also present some contribution in high energy physics, but this time with astroparticles, here also with two big international collaboration with Submarine Neutrino Telescope, Antares and KTNet. You will hear more tomorrow with my colleague Guerri on neutrino and involvement in hyperkey in Japan. All this is to highlight the fact that the involvement of Morocco in data analysis work perfectly fine. Also, involvement of Morocco in the technological aspect work also, we are very visible, which is really great. I will present later on the Atlas Cloud model, and I say it from now, this is one of the weakest points of Morocco. We are not at all visible in this side, even though there are great jobs done in Morocco, especially by CNRST and recently also by the University Mohammed VI in Degree. And I explain later on why. So before to conclude, I will present the African Supercomputer Center and take profit from this opportunity to require help both of Jean and Asren to hire the bandwidth in order to help Morocco to achieve his goal with the computing aspect. So it's really all what I will present is a result of collective effort. So thanks to all our international collaborators. Here is our group in Rabat. On top you have our personal power involved in collider physics, Atlas collaborations. In fact, Hassan Hindawi was leading the what we call ion physics. He has left now to a new position in US. We have Hassan leading and coordinating the search for dark photon, because we try at the LHC to explain why we have this dark matter. You heard certainly about it. So she is based in Geneva. Malak also, she works on Atlas. On bottom we have our person power working on astroparticle side. Jihad has defended his PhD a couple of months ago. He is coordinating all hardware activity in Morocco. Miriam in co-supervision in Paris, she worked on supernovae and Dimawi search for exotic particle in Adam. Why I am highlighting this, maybe Erdogan Marouche is not aware of it, but all these students, they managed to do their PhD thanks to the MARWAN network, because we use the network to get get data from CERN, get data from the international collaboration. And all this achievement will not happen without MARWAN. So thanks a lot to Redwan and CNRS support. In fact, Morocco has joined the Atlas collaboration since many years ago. It started in 1996. Huge collaboration which studied the collision of proton. I will not go in deep details, of course, but there are many open questions in physics. It's shame to say that even though all this development, this scientific development, we only understand 5% of the matter of the universe. So 95% is complete mystery, and one of the mission of Atlas is to bring answers to such big questions. So this is one of our recent achievements with Atlas collaborations. It concerns the search, what we call the light by light scattering. So we managed to collide two photons. If you take two photons, if you take two beam lasers, you cannot collide them. You can play with lasers that you have at home, because it's extremely rare process. Morocco has contributed to the observation for the first time of this quantum effect, exploring what we call ultra-peripheral collision of heavy ion at the LHC, because you know LHC collide protons, but also collide heavy ions like lead. So you can see we have two lead ions. They miss each other. That's why we call it ultra-peripheral. But since they are charged, they behave like electromagnetic wave, and we obtain at the final state two scattered photons. So this is one of the major achievements, I will say, recently of Morocco in the collaboration. What makes it also important is the fact that these two photons could couple to any new particle beyond the standard model, because we search all the time in Atlas for new physics, and this could provide clean way to search for new physics. So this is the result, and I will not go in deep details. I mean, if you look at what we call the invariant mass of the two photons, Atlas has registered about 59 events, while we were expecting only 12 events from the background. We have two kinds of background coming from the contribution of gluon, and also background coming for the mystery construction of event. And this was interpreted as the first time 8 sigma. So this is the statistical significance of this major observation. This is how it looks like the event of light by light scattering. So you can look at it. So this is the two scattered photons, the final state. And this is the kind of data. It's an electronic image. And Atlas take like 400 million of image per second. We cannot store them, so we have a filter, we have triggers. We only manage to store something like 1,000 images of this kind per second. Morocco also has contributed to the search for candidate to dark matter. There are particles called axion-like particles. This, of course, we didn't discover the dark matter, but we managed to push the limit. One of the best limits here provided by Atlas in this range of energy, searching for dark matter as axion-like particle. So there are many studies. We have Hesnau, who she is now at CERN. She is leading the search for dark photons in this Z-Higgs decay, where Higgs decay in one normal photon and dark photon. Of course, we didn't manage to find the dark photon, but we set again a limit on this particle. So you can see from here that Morocco is very busy visible in data analysis and physics. And we are coordinating some analysis. We are really co-authors of many important publications of this collaboration. For astroparticle side, Morocco has been with many universities part of what we call Antares telescope. It's submarine neutrino telescope. Installed, it has operated from 2008 to 2022 in the base, Mediterranean base, close to Marseille. This is lines, each one like Eiffel Tower, equipped with what we call photomultiplicator sensors. You will see details with my colleague tomorrow. We miss the construction, but we were very active in data analysis. Morocco has taken all the responsibility in these projects for the search of exotic physics. By exotic physics, I mean, I will skip, this is just a photo of lines. You can imagine the technological challenges behind this project. So we have a guy who was leading the search of magnetic monopoles. What is magnetic monopoles? You know, the electrons is the particle which is in charge of electrostatic effect. So the Iraq supposed the existence of equivalent candidate which is in charge of magnetic effect. So we were reading the search of these magnetic monopoles. So here the signal, this is the number of heated, you remember these sensors, when you have magnetic monopoles, you will detect light on these sensors. So you can see it's easy to, this is the signal of monopoles compared to signal from background due to cosmic muons. With special kind, we can easily isolate this particle if they exist. So here also Morocco was leading this study, and we managed to provide here in green and red. We didn't detect again the monopoles, but we provided the best limits on this particle, and the limits obtained thanks to Morocco and the collaboration are really competitive, especially to our let's say scientific enemy, Ice Cube. They use similar technique but in ice with more lines. So you can see we provide more best limits. Okay, we have also in collaboration with a nice guy from Mujda, we search for what we call nuclear lines. To make it simple, the atoms contain protons and neutrons, but there are hypotheses that say that they could also contain strange quark. That's what nuclear is. It's matter which contains quark. So this is the signal that we should see if we have this particle in the universe. Unfortunately, we didn't get any kind of this particle, but again, you can see in red, we have provided the best limit on this particle now in the world, and we are far away from the limits that exist up to now. Okay, let's move now to, in physics we are good. In technological aspect also we are good, because Atlas planned to move the detection from 3D, because the image I showed before, it's 3D image. You have info about X, Y, Z position, but Atlas want to upgrade to measure also time. So we want to move from 3D, 4D. For this, we need a device. We will construct what we call high granularity timing detection based on what we call low range avalanche sensors. It's ultra fast. It's about 30 picoseconds. So imagine how advanced it's this technology. I personally play a major role in order to involve Morocco in the construction of this too sophisticated device. After 1 year of lobbying, the collaboration cell was convinced also of the quality of all Moroccan researchers. Morocco has been chosen, I don't know if you heard about Masir in Rabat. It has been chosen as site for the construction of 60% of this device. Another important project is submarine neutrino telescope called KM3net for kilometer cube network. This is the collaboration. Morocco is represented here by 3 universities, Rabat, Oujda, and Marrakech. Same technique like Antares before, but with more lines. We plan to have more than 600 lines, so it's a big project. And I will skip this one. And we managed to convince the collaboration to set up a lab and a line for construction of these sensors in Morocco. So this is a photo from our lab in Rabat, and this is really the key for the telescope. It's called digital optical modules, completely integrated by our student, PhD student in Rabat, which include assembly, test, mechanic test, optic, electronics. So there are a lot of nice physics and a lot of multidisciplinary aspects in this challenge. Another contribution, important one, is of my colleague in Oujda. For the same telescope, because we have a lot of optical fiber and electric cables, my colleague in Oujda, they construct what we call the optoelectronic router for the telescope. So up to now, I hope you get the message. We are good in physics. We are also started to gain the international collaboration has some confidence in Morocco from technological point of view. But our data, we have 2 types of data in Atlas. Real data from the collision. I mentioned we have 40 million per second collision and image. We filter to get like 1,000 events, 1,000 image. So this is the chain we trigger, we have filtering, we reconstruct, and later on users can explore this data to search for new particle and do nice physics. And of course, we need to compare with what we call the Monte Carlo. We need to simulate, and it's hard task because one event, imagine we have 400 million per second, and one event takes like 15 minutes in order to simulate one event for Atlas. So imagine the CPU time required in order to have like a Monte Carlo reference to compare with data. So the cloud is organized in 4 layers. In the center you can see what we call tier 0 is the CERN. So all data from LHC pass by the CERN hub, and CERN provide like 20% of computing facility for the LHC in total. And so it's the first copy of the data from the collider. After that, we have to make a copy in this green layer, which we call tier 1. We have about 13 now, 13 big, they are basically big center with a huge CPU facility and huge capacity for data storage. Connection between tier 0 and tier 1 is about 100, at least 100 gigabit per second. And we have tier 1, basically it's university and big center who have also some facilities to store data. In total we have 160 sites for tier 2. But you need at least again about 10 gigabit minimum in order to be recognized as tier 2 in the collaboration. And you have to sign an official MOU in order to get this level. It's pity. I hate this map. You can see from here that nothing happened in Africa and North Africa, except maybe this old dot we had in the past tier 2 in South Africa, but they are facing also a lot of problem with the bandwidth, so it's not for the operation. You can get here an idea about how big is the cloud for LSC. So we have about 1.5 million of CPU cores. Storage, it's exabyte. Radwan know better than I do. It's not penta, it's scale of. And you can see the amount of data transferred between the sites, so it's huge. And again, I hate this dashboard, because when they present this, they say the grid doesn't sleep exactly, but it do in Africa and in north of Africa and Morocco included. So I hope with the help of Jean Asren, we will change the situation. You can go to this dashboard, it's public, and you will see non-stop activity except in Africa, unfortunately. So doesn't mean we have nothing. We have, you heard a lot from Radwan, and we have a national effort, especially from this University Polytechnic in Ben. We have one of the advanced supercomputer center. So you see here its characteristic is 3 pentaflop. It's a huge amount of CPU, 8,000 terabytes for storage. But to me, even though it's advanced, it's a nice city, but without tools to commute with the city. So it's. I hope this situation will change. This is the role. One of the major roles, bien sûr, is of course is to stimulate research, and Morocco wants to play like a key role in Africa. But again, I insist, without correct bandwidth, at least 10 gigabytes, because we have 1 gigabit per second, we will never manage to do it. Forgive me if I took a lot of your time. So this data center in Ben Guerir is used now. Is everything is set up? Middleware for tier 2 is ready. For tier, everything is okay. And the collaboration, Atlas collaboration, started to explore it. So we started to run some Monte Carlo jobs in this site. What you see here in red is what is missing due to this problem of bandwidth. So it's fully operational, and they are quite happy with it. You can see it's connected to the French cloud, because we are hoping to become tier 2 very soon. So we will connect to tier 1 in France, and it works fine except the bandwidth. Okay, maybe I will skip this, but we should really start to worry, because we are living in the 4th generation, and people start a lot to talk about quantum computing, which will really change the image of everything, detection, communications. So there are huge community now at the LSC working on that, including the computing in aspect. You can see here big firms that are involved in. I arrived to my conclusion to say it again and again. Morocco is doing well with physics analysis, involvement in technological aspect, but still we have to do a lot in terms of computing. And one of the major things I require from Asren and Jean is please help us to upgrade the bandwidth at least to 10 gigabits. Thank you. I invite the speakers maybe to join me.
Bonsoir.
Barbouchi. from Daily Apps Morocco. The presentation of Mr. Taha is MOOS, an open cloud computing platform for research and educations. I also invite Mr. Bissem, Mrs. Namira, if she's here, to join Mohammed Al-Habban. So we are missing speakers for this last session. I think he is not.